What's up? You did it. You made it to level 7. 7.1. What's up? You did it. Proud of you. You did it. Well, this level, I have to warn you, it's a little hard. All these lessons are a little bit hard, all right? And you're going to be learning a lot about parallelograms, all right? A lot about it. There's different kinds of parallelograms you're going to be learning about, but for this lesson, we're going to talk all about parallelograms, and we should probably start off with what a parallelogram is. So let's get into that. So a parallelogram is a quadrilateral, and if you don't know what a quadrilateral is, let me tell you, that is a four-sided figure. All right, it's a four-sided figure where both pairs of opposite sides are parallel. All right, the opposite sides are parallel to each other, hence parallelogram. So what does that actually look like? Well, what it tells me is that AB and DC, if these two are parallel, all right, so you see these are one pair of opposite sides, and then CB and DA are parallel, all right, and these little markings means parallel. Well, then this would be a parallelogram, all right, because my opposite sides are parallel. So if I knew that AB is parallel to DC, and I knew AD is parallel to BC, well, then I know that what we have here is a parallelogram because opposite sides are parallel. Now, there's more properties that are true for every parallelogram, okay? And let's get into that. So, we know opposite sides are parallel. That's pretty cool, but there's more, all right? Now, if a quadrilateral is a parallelogram if opposite sides are congruent, all right? So you know a quadrilateral is a parallelogram if the opposite sides are congruent. So what would that look like? Well, BC and AD are opposite sides, and let's say they're congruent, and BA and CD are opposite sides. So let's say they're congruent. So if BC and AD are congruent, and BA and CD are congruent, then opposite sides are congruent. All right, and that means that this must be a parallelogram. All right, so if opposite sides are congruent, then you know it's a parallelogram. There's more ways to tell if something's a parallelogram. All right, now if opposite angles, a quadrilateral is a parallelogram if opposite angles are congruent as well. So let's say B and D are congruent to each other, so those are opposite angles, they're across from each other, and A and C are congruent to each other, well, then this would be a parallelogram because opposite angles are congruent. Opposite angles are congruent. So if I know B is congruent to angle D and A is congruent to angle C, then I know that this is a parallelogram because opposite angles are congruent. All right, so we got three properties. Let's do a quick review. We know opposite sides are parallel. If opposite sides are parallel, then it's a parallelogram. If opposite sides are congruent, then it's a parallelogram. If opposite angles are congruent, then it's a parallelogram. And then we got two more, all right? So we know a quadrilateral is a parallelogram if the consecutive angles are supplementary. So what are consecutive angles? Those are angles that are next to each other, next to each other. And what is supplementary? Just a reminder from last unit, that's 180 degrees. So if consecutive angles are 180, then we know it's a parallelogram. But all the consecutive angles have to be 180. So what does that look like? Well, let's say B is 100 degrees, all right? The consecutive angle would be A, 80 degrees. So if B and A add up to 180, then we know, well, that's one thing we need to know. Well, if this is 100, and this was a parallelogram, this would also be 100, and this would be 80. So B and A, well, that's 180. A and D, if those add up to 180, C and D, those add up to 180. And then C and B, those also add up to 180. So if the consecutive angles are supplementary, then we know that it is a parallelogram. All right, that's true for all parallelograms. And then finally, we know a quadrilateral is a parallelogram if the diagonals bisect each other. Now you might not have seen this word before, but it means cuts into two congruent halves. So what does that mean? That the diagonals bisect each other. Well, if diagonals bisect each other, that means that this piece, BV, is congruent to VD. BV is congruent to VD because this point cuts it in half. And then we also know AV is congruent to VC because this point cuts in half. These diagonals cut each other in half. So BV is congruent to VD, and AV is congruent to VC. All right, the diagonals cut each other in half. All right, these are all the properties you need to know. If you know these, the rest of this is going to be cake money. That's not a thing, I just made it up. All right, so let's say we were given this. In quadrilateral ABCD, we know that angle B is congruent to angle D, and angle A is congruent to angle C. We want to prove that ABCD is a parallelogram. Well, how do we do that with this given information? The way we prove it is to say this. Quadrilateral ABCD is a parallelogram because, well, what did we learn? Because opposite angles are congruent. Remember, if opposite angles are congruent, then this must be a parallelogram. And that's why they gave us this. All right, that's one example. In our second example, it says in quadrilateral MNOP, diagonals MO and NP intersect at point T. So that would be right here. We know that MT is congruent to OT, and we know that NT is congruent to TP. So how do I now know that this is a parallelogram? Well, the way is this. We know quadrilateral MNOP is a parallelogram because the diagonals bisect each other. So that means this diagonal right here, so PN, cut MO in half, you see, into two congruent pieces, this piece and this piece. And MO cut PN in half, this piece and this piece. So since the diagonals bisect each other, it is a parallelogram. Let's do another one. In quadrilateral WXYZ, we know that WX, and we're going to use this symbol right here, that's the parallel symbol, is parallel to ZY, all right? And we know that WZ is parallel to XY. Prove that WXYZ is a parallelogram. Well, that's pretty straightforward, right? The way we do this is just use the sentence we've been using. So we'd say quadrilateral WXYZ is a parallelogram. You notice that we're just using the same phrase here, it doesn't have to change, because opposite sides are parallel. So we're just using the properties that we learned on the last page. All right, if we know one of those properties is true, then it must be a parallelogram. And finally, our last one, in quadrilateral ABCD, we know AB is congruent to DC. What additional information is needed to prove that ABCD is a parallelogram? Well, first, nothing's drawn here, so we should probably draw it out ourselves. Let's go for it. ABCD. Oh, that's crap. Let's try this again. All right, that is my attempt at a parallelogram. All right, so we have A, B, C, and D. Now we know that AB is congruent to DC. And it says what additional information is needed to prove that ABCD is a parallelogram? Well, we know one pair of opposite sides are congruent. If we had another pair of opposite sides that were congruent, well then we know that this is a parallelogram. So if AD is congruent to BC, then we know that this is a parallelogram. So quadrilateral ABCD is a parallelogram because, and what property did we use here with that additional information? Opposite sides are congruent. All right. So if any of the properties you learned in the last page are true, then it is a parallelogram. Opposite sides are parallel, diagonals bisect each other, and on and on and on. You can look at the page. You can look at it. All right. So now we're going to be working with some numbers. So in parallelogram WXY, get out of here. WXYZ, angle Z is 68 degrees. All right. Find the measure of angle W and justify your answer. So we want this angle right here, angle W. Now what we know here is that these are consecutive angles. They're next to each other. They're not opposite. So these are consecutive angles. And what do we know about consecutive angles in a parallelogram? Well, they add up to 180. All right, so if I wanted to find 1W, all I would have to do is 180 minus 68, and that would give me 112 degrees. So this would be angle W, 112 degrees. And that's because consecutive angles are supplementary. All right, and you know what? Just get in the habit of filling the rest of the angles as well. We know opposite angles are congruent, so just fill them all in. It's just a good habit. You'll get good at that. For our second one, angle A is 75 degrees. Find the measure of angle C and justify your answer. Well, let's see. Angle A is 75 degrees, and I want to find C. Well, if you notice here, A and C are opposite angles, so this would also be 75 degrees. So measure of angle C is 75. And why? We know in a parallelogram, opposite angles are congruent. Easy stuff here. Now this word gets a little bit more difficult. All right, so follow along. In parallelogram MNOP, NMO is 62, angle P is 48 degrees. Find the measures of 1, 2, and 3 and justify your answers. Well, this is a little bit more difficult, so you might want to pay attention closely. The first angle you could find is angle 1, and this is not because of our property that we've learned directly, but what you know is this. We know that MN is parallel to PO, right? And then we know that MO is our transversal. This is a transversal of our two lines. If this is a transversal, that would mean that this angle and this angle are alternate interior angles. See what I just did there? If these are alternate interior angles, that means that this is also 62 degrees. All right, and so angle 1 is 62 degrees, and that's because alternate interior angles are congruent. Now to find angle 2, what you might notice now is that we have a triangle. See, we have a triangle right here? So to find this missing angle, I already have two angles. I would just do 180 minus 62 minus 48, and what that would give me is 70 degrees. So angle 2 is 70. And the way I found that out is once again because of the triangle sum theorem. And then finally, our last one is angle 3. And once again, these are alternate interior angles again because they're on opposite sides. So this is 70 degrees. So angle 3 is 70, and that's because of alternate interior angles. All right. Hopefully you got that. Remember, parallel lines with the transversal, that is alternate interior angles. All right, for this last one, you know what I'm going to say? Try to figure it out and see if you can. So pause the video, see if you can figure this out for yourself.